We're going to make this the best experience ever for you all. Oh, good, Tilly. Woo! Good job. Good job. How are you doing? You ended chemistry with a 93. That's what's up. You got that A. And I love hearing that. There we go. I want to make sure I was on. As you guys can see, I am here. Okay, so yes, I just got through working out. Okay, so I'm looking like a hot mess, but that's okay because you guys are here anyway for chemistry, so you could care less what I look like, right? But that's so great to hear. I love hearing the good news about what you guys are doing in terms of passing your class. You are the second student today that's told me that you have passed your chemistry class. So I appreciate you all for tapping in with me to remind me of your greatness, to remind me of the things that you guys are doing to succeed and pass your classes. Yes. Hey, Talon, we are doing different topics. I've had a lot of people that have come on for the past couple of days letting me know that they're from New York. And because they're from NYC or just New York, okay, some of the students have asked me to do different topics. So I have a student on here right now. Ariana, are you still here in the building? Don't be telling me you hate chemistry. Because what I'm going to do tonight is go over she wanted to know about molarity. So I'm going to do some molarity problems. So, okay, good. Ariana, I got you covered, honey. I got you covered. So let me go ahead and pull up something that I can go through, to help you out on that with molarity. So let me see if I can find some stuff really quickly. I got plenty of stuff for y'all. Let me see here. Molarity, molarity, molarity. See, I have so many different worksheets and so many different things. So I just want to make sure. Okay, I'm just going to pull this one as an example right here. Okay, so, oh, and I got to change my screen so that YouTube can see this also. All right, so the new request was for me to do something on molarity. Okay. Oh, got you, got you, got you. I'll take care of you right now. Okay, and you want to know what's the difference between molarity and limiting reagents? Okay, there is a big difference with those two. So I'll go ahead and help you on the first one, and then I'll get to you on limiting reagents. So here's the deal with molarity. If you are given a problem such as the one that you see on the screen, let me zoom in, okay? Molarity deals with, of course, moles per liter, okay? So that means you're going to be given a certain type of problem to solve either for molarity, for the moles, or for the volume. So here's the formula right here. Molarity is equal to moles per liter. Now I can also flip this formula and solve for volume, which is liters, and put moles divided by molarity, okay? And then I can also solve for moles, which is simply molarity times liters or times volume. So when you know that you have three different formulas that you can use to solve for each problem, you have to also realize that when you see moles, you're going to also deal with conversions, possibly. Now, what do I mean by conversions? In this particular case, if you look at this problem right here, it says, what is the molarity of 60 grams of sodium hydroxide in 0.2570 liters of sodium hydroxide? Now, in a problem like this, because you know the formula for molarity is moles divided by liters, you don't see a mole anywhere in this problem. So what you would have to do is convert the 60 grams of sodium hydroxide to moles, okay? So let me go ahead and scroll this down a little bit. And what we know, we got 60 grams of sodium hydroxide that we've got to convert to a mole. Now, I know in order to convert anything to a mole, we must know the molar mass of that compound. That's right, Van. Very good. Divide by the molar mass. Correct. So the chemistry got you tweaking. Okay. So the molar mass of sodium hydroxide. Now, y'all, I've been doing this for 1,000 years, okay? And so I know that the molar mass for sodium hydroxide, I believe, is 39.10. Let's double check that. The mass for sodium is 23.99. Jenny, I've been here, honey. I was here yesterday. Sodium is 22.99 plus 16 for hydrogen, oxygen, and plus 1.01 for hydrogen. So the molar mass for sodium hydroxide is 40.00 grams of NaOH. Now, what you're going to do is cancel out your grams of sodium hydroxides, and you're going to end up with 60.0 divided by 40.00. Here is the deal, though. You need to make sure that you have the correct number of significant digits because, yes, that's right, Ariana. I just simply added sodium plus oxygen plus hydrogen's molecular weight on the periodic table. Okay, yeah, that's how we got it. Okay, good. So now when you take that 60.0 and divide that by the 40.00, you're going to get 1.5 moles of sodium hydroxide. Okay, 1.5 moles of sodium hydroxide. Now we're not done because if you look at the problem, they gave you liters also, 0.25 liters of sodium hydroxide. Now, what we just found was the moles. So because we're trying to find the molarity, which is, of course, is moles per liter, we've got 1.5 moles of sodium hydroxide divided by 0.250 liters. Yes, this is General Chemistry 1, an Introductory Chemistry 1, High School Chemistry 1, AP Chemistry. That is all of the above. So now 1.5 divided by 0.250 gives us 6. So the molarity for this is 6. But now let me tell you, you want to make sure that you put, and I got to put this as 1.50, okay? Because we need to make sure that we keep up with our sig figs. 6.00 big M for molarity. Hey, Rosalind, how you doing? Oh, good, T. Scott. Congratulations on getting an A on your first chemistry exam. That's the way you start off. Okay, very good, very good, very, very good. All right, so now what we're going to do, okay, I got all y'all's requests. I'm getting there. I'm getting there. Okay, I'm getting there. Van, I got you if you need help on General Chem 210. All right. So now what are you going to do? That's it. So with molarity, you're going to either use formula number 1, formula number 2, or formula number 3, depending on what they ask you. Okay. Depending on what they ask you. Now, what I also know, okay, Llama Bird, Okay, Rosalind, you want to see the question? Right here. Can you see that? Good job, Madeline. Yes, okay, yes, I can. I can do that for you, Ariana. So when you're dealing with molarity, okay, this is just one example here, okay? So let me also show you another example in terms of how do you know which formula to use, okay? Another way to help you remember this is there's this concept here, okay, or this formula where if I were to ask you, how do you know which formula to use, okay? Do this right here. I'm going to put molarity, moles, and liters. Okay, here's the easy way to remember this. Okay, I know, Joel, you know what? Oh, good. We need to keep pushing TikTok to get me on that FYP all the time. If we cover up the M, guys, the formula for molarity is moles divided by liters. Okay, this is an easy way to remember it. If you draw this triangle right here and you put the M on the very bottom and you cover it up, it's moles divided by liters. If I cover up the L for liters, it's moles divided by molarity. Okay, divided by molarity. On the other hand, if let's say I cover up the moles, then of course that's going to say molarity times liters. Those are quick tips to help you remember these formulas. Now, by the way, this replay is going up on my YouTube channel. Right now, I am live on YouTube, so you guys can go follow me over there as well in order to know if you want to go back and look at this, throughout the week and on the weekend as you guys are preparing for your final exams, okay? Now, here's the other thing too. If you want to know how to use this problem, let me pull another example for you because I know oftentimes you're going to be given different types of molarity problems that you'll have to know how to solve for, okay? So I'm going to cut this one out and I'm going to do this one for you all as well, okay? So right here, here's another example, okay? And I'm going to zoom in so you all can see this, okay? It says, whoop, I've zoomed in too much. How many liters of a 2.00 molarity sodium chloride solution are needed to provide 67.3 grams of sodium chloride? Okay, so here is the deal with that. In a problem of this nature, they're asking you for volume. So again, if you go back to our formula, L is equal to moles divided by molarity. In other words, your volume is equal to moles divided by molarity. Now, in this problem, they gave you 2.00 molarity. So you got the bottom number, but over here, they gave you 67.3 grams of sodium chloride. Now, in this particular case, like most teachers do, we try to challenge you to go extra, okay? So right here, it's not just straightforward to give you the moles. You've got to actually do what? Convert the grams to moles. So again, what you're going to do, whatever you're looking for, you're going to put that on the very top. Whatever you want to get rid of, that's going to go on the very bottom. Because what I'm going to do now is cross out the grams of sodium chloride. But remember, I need to know the grams of sodium chloride. Thank you. It's May Basu. Honey, I'm jacking it all the way up. But thank you for providing me with the molar mass of sodium chloride, which is 58.35. Okay. Now, again, if you forgot how to find the molar mass, okay, of sodium chloride, again, you're just going to look at your periodic table. And for sodium, it's 22.99 plus chlorine's molar mass weight, which is 35.45. And all you have to do is add those two numbers together and you get 58.44. I put 35, but it's 44. Okay. Now, what I'm going to do is divide those two numbers. Yeah, okay, yes. How did I get those numbers? Again, this is from the periodic table, okay? The periodic table. So I'm going to show you in my book right here, because I could pull up one on the online, but if you see sodium's weight is 22.99 right there, 22.99. And then chlorine's weight is 35.45. So that's where I got those two numbers from, okay? So now all I'm going to do is divide those two numbers, 67.3 divided by 58.44. And I get 1.15, okay? 1.15 moles of sodium chloride. Now, again, we're not done because they ask us to find the molarity. So, I'm sorry, they asked us to find the volume, the liters. So, remember, liters is equal to moles divided by molarity. Now, watch this. I've got 1.15 moles. And on the very bottom, let's go back up here to find what the molarity was. 2.00, see right there, 2.00. And I'm just going to simply change the unit of molarity to moles per liter. If you all didn't know, remember, molarity is equal to moles per liter. So I just rewrote that because I want to make sure that I'm able to cancel out my moles, okay? And now whenever I do that, all I have to do now is simply divide those two numbers, 1.15 divided by 2.00, and I get 0.575. Using 3 significant digits, and that's in liters. Okay, now Brandon 1203, you want to know about pH and log of pH? So we'll try to get to that also. I'm going in the order that some of these questions were coming up for me. Okay. If I missed your question, put it back up on the screen. Okay, you said, doesn't the units flip? Well, remember, if you have the mole that's on the top cancels out the moles that's on the very bottom. Okay, so the moles actually cancel out. So they're not flipping, they're actually canceling out, and you're left with liters. Oh, yes, elementary agents. Yes, I got you on that. Yes. Nomi, yes. So you want to know what's the difference between molarity and elementary agents? All right, I got you. So with elementary agents, there's a problem where you're trying to figure out which one is going to prevent you from moving forward within your problem, okay? Like in your chemical reaction. So with the elementary agent, my YouTube channel is Learn Chemistry with Professor TK the Chemist. And it's actually in my bio. So if you click that link, it's going to take you straight over there to my YouTube channel. Yep. So with elementary agents, it's going to tell you the element or compound that's going to stop your reaction from going further. Okay. In other words, like if I have, oh, I got a good example. If I have 2 pieces of bread plus 1 piece of meat to give me 1 sandwich, and let's say I have 5 pieces of bread, okay, and no pieces of meat, the limiting reagent is going to be the meat, meaning the one that you run out of first, okay? The one that you run out of first. That's your limiting, because that's going to prevent you from actually moving forward with your chemical reaction. So I'm trying to find one in my book. Thank you, Seymour 279. Correct. It's like you can't bake more cookies when you run out of butter. Yes. Okay. A man, can you help with fusion? Okay. Hold tight. I'm going to get there too. I'm going to get there too. Okay. So I'm trying to find one. Matter of fact, I'm going to pull this up online. Okay. Because somebody had asked me about limiting reagents, and I actually did those problems also. So I'm just pulling up some of my old lessons from earlier this past semester to make it quicker and easier for you all. Okay. So I'm just trying to pull up notes quick because I know that we're on a time schedule here, in terms of the me teaching this information. So I have a problem that I've already done on limiting reactants. So what I'm going to do is just basically show you and explain to you how to solve this problem. Then I'm going to get to the fusion, okay? Now, Aman, can you tell me, what do you want to know about fusion? Okay, tell me, what do you want to know about it? Is this a nuclear chemical reaction problem that you want to know? Okay, so with limiting reactants, let me go ahead and help you guys out on that. Wait, so what's the difference between limiting reagents and limiting reactants? Okay, good question. So here's how you can remember this. Reactants, basically, when you're dealing with limiting reactants, it's basically the reactant side that's going to be the limiting. It's going to be one of these compounds that's going to prevent your products from producing what they need. Okay, so it's the reactants, one of those reactants that's going to be the limiting one. No, not really, Nomi. The only way you could use that is if you were, if for some way they were asking about molarity, but in this particular case, no, like, because what you're doing, okay, if they give you the problem in molarity, you could potentially use that. Most of the time, they're going to give it to you like in moles. So I'm going to show you. Let me go ahead and break this down for you, okay? So in this particular problem right here, I'm gonna zoom into the question so you all can see it. Calcium hydroxide, okay, we don't care about this part right here. Let's just get straight to it. You've got the chemical reaction, okay, right here. It says if you spilled 6.3 moles of hydrochloric acid and you put 2.8 moles of calcium hydroxide on it, which substance is the limiting reactant? Okay, here's how you do this. You first got to make sure that your reaction is properly balanced. Yes, it's balanced. In this case, it is. Start with the first number that they give you, okay? It says 2.8 moles of calcium hydroxide. And what you're going to do is use those coefficients from your chemical reaction. So in this particular case right here, okay, because they were concerned about hydrochloric acid and calcium hydroxide, you're going to use those two as your coefficients for this part right here. So notice how I take the 2.8 moles of calcium hydroxide. That's the first number that I write. On the very bottom, I'm going to put 1 mole of that because that one comes from calcium hydroxide right here in the chemical reaction. On the very top, I'm putting 2 moles of HCl. So when I multiply 2.8 times 2, I get 5.6 moles of hydrochloric acid. Now, as you continue to look at the way I solved the problem, okay, what you simply had to do was to determine which one of these elements here, or compounds rather, is going to be the limiting reactant. So as you notice here, I get 5.6 moles of HCl, right? Based on this amount, more HCl, which what they gave you in the problem was 6.3 moles, is available than is needed to react with 2.8 moles of calcium hydroxide. Therefore, hydrochloric acid is present in excess, making calcium hydroxide the limiting reagent. So in other words, if you noticed here, we took the 2.8 moles of calcium hydroxide and we compared that to the moles of hydrochloric acid. When we multiply those two numbers, we get 5.6 moles of HCl. So in other words, this small number here compared to the 6.3 that's given in the problem tells us that the HCl is in excess. Okay, you have more of that for this problem. Okay, let me do another. I think I got another one down here. Oh yes, and see, I was trying to show it to you so that way you're able to see the problems from top to bottom. So let me give you another example. Okay, and then I'm going to do the fusion problem. In this particular reaction here, it says nitrogen and hydrogen react to form ammonia. So what you've got, you have N2 plus H2 gives you NH3. So in letter A, just look at letter A only, okay? They gave you 3 moles of nitrogen and 5 moles of hydrogen. And we're trying to determine which one of those is a limiting reactant. So in other words, between nitrogen and hydrogen, which one is going to prevent us from moving forward or moving further? So in this particular problem, all you're going to do, okay, because they gave you 3 moles of nitrogen and 5 moles of hydrogen. I'm going to scroll it up a little so y'all can see this, okay? We're going to use the coefficients for each of these formulas. 1 mole of nitrogen, 3 moles of hydrogen, 2 moles of NH3, ammonia. What was given, though, in the problem was 3 moles of nitrogen and 5 moles of hydrogen. So I'm going to start with the 3 moles of nitrogen first. 3.0 moles of nitrogen times. Again, you're going to compare that to the product, what was produced. 2 moles of that over 1 mole of nitrogen. That gave us 6.0 moles of NH3. On the other hand, the other number that they gave us was 5.0 moles of hydrogen. Again, you're going to compare that to what was produced, the 2 moles of NH3. And on the very bottom, the 3 moles of H2. Again, that's coming from your coefficients right here. The numbers that you see on the bottom are coming from the coefficients in your chemical reaction. Now, when you do your calculations and you multiply 3 times 2 and 5.0 times 2 and divide that by 3, one of these numbers is the smallest. The one that's the smallest is your limiting reactant. So in this case, we know that hydrogen is the limiting reactant. Rosalind, you say it's lagging. I don't know why. I don't know why. Disgusted, I'm glad you love chemistry. I do too. I do as well. Okay, Norma, you said you can see it well. Okay, good. Sometimes you may have to go out and come back in. Okay, yes. Yes. So as you can see, the one that was the smallest number that was produced, that's the one that was the limiting reactant. And in this case, it is hydrogen. Okay, so hydrogen is a limiting reactant. Now, if we do another example, okay, let's say that we were doing letter B. Letter B. Again, we still are looking at the chemical reaction here, nitrogen plus hydrogen producing ammonia. 1 mole of N2, 3 moles of H2, 2 moles of NH3. That's what was given right here. They gave us in letter B 8 moles of nitrogen versus 4 moles of hydrogen. What we're trying to figure out is which one of those is going to produce the smallest amount of product. So if you look at what you were given here, 8 moles of nitrogen times 2 moles of ammonia. Again, what was produced is going to go on the top. That's what I have in red right there. Thank you guys so much also for sharing this live. I really appreciate you guys. Thank you so much for the follows. I am noticing what you guys are doing, but I'm trying to also make sure I keep it going because I know I'll get off task. But I thank y'all for that. Thank you, appreciate the love so much. So because I gave you 8 moles of nitrogen, I'm going to put 1 mole of nitrogen on the very bottom. But remember, on the top, what was produced was the 2 moles of NH3. 8 times 2 gives us 16. On the other hand, they also gave you 4.0 moles of hydrogen. What we want to get rid of are the moles of hydrogen. That's why that 3 is on the very bottom, right here. Ammonia is on the very top. So again, you multiply 4 times 2, divide that by 3, and you get 2.7. So which one of these numbers is the smallest? The one in yellow or the one in blue? Put a color heart in the comments if you can tell me which color is the smallest. The one in yellow or the one in blue? Either put the color name or the color heart. Let me grab my water. Y'all, I worked out before this live, so I got to make sure I stay hydrated. Okay. Yes, the blue. That is correct. So therefore, because the blue is the smallest number, that means hydrogen is the limiting reactant. Okay. Hydrogen is the limiting reactant because it produced the smallest amount. Okay. Now, I know someone else came through and they said they want to know about fusion. Are you still here with me? The person that asked about fusion? Okay, you're welcome. You're welcome. Okay, so let's see. What do you want to know about fusion? So I know, okay. This is a nuclear chemistry reaction. Thank you, Rosalind. Appreciate you. Appreciate you. Fusion, let me tell y'all, it's just simply saying, what are we going to do to make some ish go kaboom? Okay. That's what we're talking about. What kind of reaction can we get to make some stuff go kaboom? Okay. So I don't think I did. Let me see. I may have done a fusion earlier this year. Let me check. I gotta pull up my notes right here. Let me see. Well, this is like nuclear chemistry. Let me see. I don't know if I got it. If I do, I'll pull it up. Let me see. Okay. Kind of, sort of, I do, but I'm going to actually break it down for you so that way you'll know, okay, what we're doing right here. So with nuclear chemistry, let me zoom in so you can see that. Okay, wait, what type of questions they may ask? Okay, good question. So here is the deal, okay? When it comes to nuclear reactions and gamma rays, alpha rays, and what's the other one? Beta. There we go. You need to know the difference between them, okay? So here is an example. I'm going to write something on the screen so that way you can see it. Okay. Alpha particles, okay? Alpha, whenever something undergoes alpha, that means it's going to change by the top number and the bottom number. So this is alpha decay, okay? Alpha decay. If, on the other hand, you've got, let's say, beta, okay? Beta, that's 0, and I'm actually writing it backwards, so let me put it the correct way. Beta is 0, -1. And it's actually, it looks like a B, but you can also see a little E as well. So you can do this way or that way. It's like a funny shaped B, okay? And again, this is beta. Positrons are, this, it looks the same, but the difference is with positrons, it's 0 + 1. And that little funny shape E, or that E, or it looks like the B with the plus sign. And then with gamma, gamma is 0, 0. So in other words, that never changes, like the top number or the bottom number never changes. So whenever you're doing these types of problems, you have to know what type of energy, nuclear energy, you're going to hit it with, okay? So in this particular example here, because I know those are like the 4 symbols for nuclear reactions and nuclear chemicals, chemistry rather. In this particular example here, let me just show you number 4 so you can see. They may ask you to find the missing particle, okay? For instance, so for number 4 right here, okay, I'm going to highlight this so you can see that. What is the missing particle? So if on the left-hand side, you were given 231/90 in thorium, what you're trying to figure out is what radioactive material responded to this chemical reaction. So on the top, what you got to remember is that 231 is what you got on the left side. Put a little equal sign, and you're trying to figure out what number plus 227 is going to give you that top number. Well, I know that 227 plus 4 gives me that number. So 4 is going to go on the very top. But if you didn't know that, you just subtract 227 from both sides. And so your X is equal to 4. Now, I know also on the very bottom, 90 is on the left, 88 is on the right. Well, what number plus 88 is going to give you 90? 2. So therefore, this is going to be 4/2, which is equal to alpha particles, okay, aka helium. Correct. So JTB_8, you are correct. Thank you. Yes, this is alpha particles. Okay, this is alpha particles. So, and as you can see here, this is the example that I gave you also below, right here. Let's do the next one, number 5. Again, they're going to ask you, again, if you notice here, 231 is on the very top on the left side. 231 is the same on the right side. So I know that the top number doesn't change. That's why it's 0. However, on the bottom, you've got 90 on the left, and on the right, you're trying to figure out what number plus 89 is going to give you 90. Well, of course, it's going to be 1, but what type of 1? Positive 1 or negative 1? Okay, so if you subtract 89 from both sides, X is equal to positive 1. So in this case right here, it's going to be equal to positron. So letter A. Yep, letter A. Very good, guys. Very good. And it's a funny shape E, but positron can also be denoted with a funny shape B with a plus, kind of like B positive, okay, blood, so to speak, okay? So they could easily ask you all questions like this, okay? I may be able to pull one from my book also. Oh, here's another example right here where you'll have to find out, okay, it says, what is the main product when 23290 thorium undergoes beta decay? Okay, here's the deal. They're telling you 23290 undergoes beta decay. So that's what they're telling you here. So they want to know what's the main product. In other words, what is this side? Okay. So if you got 232 and you know they're telling you it undergoes beta decay, here's how you do process of elimination. Get rid of the answers that don't make sense. We know that the top number is going to be 232. So if you know nothing else, I know that 232 plus 0 is going to give you 232. So we can actually get rid of letter A because letter A has 238 on the very top. Yes, a man. Yes, you can. Yes, you sure can. And on the very bottom for 90, well, we know we can't just keep it at 90, okay? So we know it's not letter D. Now, the reference material that you're referring to, I'm going to ping over to that so that way everybody will know what you're talking about, okay? So in this particular case right here, because we know that 232 did not change on the top, but we got 90 plus 1, okay, which is 91, we look at our periodic table to identify atomic number 91, and atomic number 91 is Pa. So that's why the answer is letter C. Now, for those of you all that are asking, can't we just use the reference table? And you're probably wondering, well, what reference table? Let me show you the reference table that a man is referring to. Let me see if I can pull it up. Let me stop the share right here. Let me see. Oh, there we go. Okay, so this is the reference table right here that we're referring to. Yes, Miles Nation. Yes, 232 is the mass number, but you don't use the mass number to identify your element. You use the atomic number, which is the bottom number. So now this is the table right here that you guys need to know. This is the reference tables that students must know, okay? And let me tell y'all, New York gives more than what we do down here in North Carolina. No, Leah or Legia, Legla, I'm sorry, and if I'm mispronouncing your name, don't be scared. You're not gonna fail. You're not gonna fail. As long as you've been doing everything that you're supposed to do this entire semester, you're gonna do well. Hopefully your teacher has been giving you all practice guides and study questions that you all can do each and every day leading up to your big tests. But if you go to the chart, okay, they give you a whole lot of stuff. Well, listen, QWY, if you failed all of your chemistry tests, I don't know what to tell you, honey. Okay, so right here, okay, notice they have select polyatomic ions. And for North Carolina, we don't get half of this, okay? We don't. Y'all got a lot of stuff, but you just got to know how to use it. So to go to that question, and I mentioned y'all have a lot of answers in your study in this table. The one for that, yep, this is it right here on the nuclear symbols that are used in chemistry. That's it right there. Yes, I love Chad's prep chemistry. Yes. Chad's prep chemistry is the bomb also. Okay, Maddie. Oh, okay, Miles Nation, STP, standard temperature pressure. That just simply means that your temperature is going to always be 273 Kelvin. Your pressure is going to be 1 atm. So if they're giving you a problem with STP conditions, you're going to always make sure to put the pressure is 1 atm and the temperature is 273 Kelvin. Now, what do you mean, Maddie? What do you want to know about heat unit? You're welcome. So, Chris, what do you mean my favorite topic? I love all chemistry. Every topic is my favorite. However, organic chemistry, oh, we had a love-hate relationship. It's funny that you pop in saying that, Leisha, with me saying I didn't particularly care for organic. So, yeah, what do you want to know about heat unit? Okay, heat capacity and specific heat. I've got questions on that too. Let me see. Let me see if I can pull some stuff up for you as well with that heat capacity, specific heat. Matter of fact, I think I did a couple of those problems too. Yeah, specific heat. Okay, well, maybe not. Let me see. Okay, let me screen share differently. So again, for those of you all that are hopping on, this is on my YouTube channel. So everything that we're covering tonight is on my YouTube channel. So you will have different things that you'll need to know. Okay. So let's see here. So Maddie, I got you covered. These are some of the formulas that you'll need to know right here for specific heat. Okay. So the one that's in pink, if you're trying to find the energy, okay, that's joules over grams, or your mass rather, times delta T, the change in temperature. If you're trying to find the mass, that's your joules or your energy divided by your E, okay, your energy times the change in temperature. And if you're trying to find your joules, that's equal to the energy times the mass times the change in temperature. Most of the time, you'll have to do some calculations to know that 1 calorie is equal to 4.184 joules. Okay? So they're going to give you things like that you'll have to know. And then, of course, 1 kilocal is equal to 0.004184 kilojoules. Okay, kilojoules. You're welcome. Well, okay, you want to know, do you have to memorize these formulas? So let me go back to that chart, okay? The table that the Regents exam will have, this reference table right here. Let me just kind of go through it so that way you can see what you'll have to know, okay? So right here, they give you specific heat capacity for water, okay? Again, these are like common numbers, common values that are provided, okay? Common numbers and common values that are provided. That's right. Yes, it is on the reference table. Yes. So sometimes they may give you the heat of fusion for water. They'll give you the heat of vaporization. So if you're doing a problem of this nature, you can easily refer to this chart to find the answers. Okay. Let me see if I can do one for you also. Let's see. Heat of fusion. Okay. You're welcome. Okay. So you'll also want to know that graph that they give you also that deals with this. Okay. So okay, I'm gonna read this problem out loud to you, and I'm gonna ask you to do it. Okay. Well, I can show it to you. Now, YouTube, you can't see this, but I'm going to actually read it from my book. I'm going to ping it over though, so that TikTok can see it. So I'm right here for this one. Okay. It says ice bags are used by sports trainers to treat muscle injuries. If 260 grams of ice is placed in an ice bag, how much heat in joules is absorbed when all the ice melts at 0 degrees Celsius? Okay, let me do that problem. Okay, I'm going to give you everything that you need to know for this problem. Okay, so let me go ahead and do that problem for you, so that way you'll know what you have to do. Okay, so okay, let me zoom out. Okay, so let me again, I'm going to say it again. They gave you 260 grams of ice. Okay, so in this particular problem right here, you were given the mass, which is 260 with a decimal on the end, to say that that's 3 significant digits. So 260 grams of ice is placed in an ice bag. How much heat in joules? So you're looking for your joules. Okay. In other words, you're looking for the heat is absorbed when all the ice melts at 0 degrees Celsius. So they gave you the temperature of 0 degrees Celsius. So they want to know how much heat, okay? So what you got to remember from that chart that they gave you, the heat factor here is that 1 gram, okay, of water is equal to 334 joules. Okay, that was what was given on that chart. So again, I'll just write it down so you all can see that again. 1 gram of water, okay, is equal to 334 joules. Whoops, let me back out. So this is what they gave you, okay, on that chart, the table that you guys got to know. Now, what you're going to do is take that 260 grams of water and you're going to convert that to the joules. On the bottom, we're going to put 1 gram of water. Remember, the unit that you're trying to get rid of must go on the bottom so that your units can do what? Cancel out. So your grams are going to cancel out. And on the very top, we're going to put 334 joules. Okay? So all we're going to do now is multiply 260 times 334. And that gives us, okay, I'm going to write all the numbers out, 86,840 joules. But you have to remember, guys, significant digits plays a role in your test, okay? You only need 3 of those numbers. So, and if this is a part that you have to, let's say, write out to show your work for, you best believe that sig figs is going to be a factor. So I'm highlighting the first 3 significant digits here, the 8, the 6, and the 8. But what you have to do is look to the right of that, okay? This 4 tells that 8 to stay put. But you have to still accommodate for those other numbers. Okay, I know sig figs are so annoying. You're right, honey. You are absolutely right about that. I know. You're going to end up with 86,800 joules. And that's still your 3 significant digits. Just because you said 86.8, you cannot forget about the 4 and the 0 in terms of placeholders. You still got to accommodate for those two. So 86,800 joules. Okay. Now you also asked about specific heat. Let me see here. Specific heat. Oh, I see. That's the thing I can't show y'all on YouTube. That I was going to pull up something, but I can't show it to you all on here. I was going to try to find one for y'all to do, but I can just kind of verbally again say it. Okay. And it's funny that this problem deals with being sore because, like I said, I just finished working out before I got on this live. And I know I'm always sore. I take Epsom salt baths every time, especially when I'm doing strength training. When I'm running, I'm usually sore if I'm going beyond my threshold. Thank you, bro. Appreciate you. Appreciate you. You helped me pass chemistry with the B last semester. That's what's up. That's what's up. Thank you, thank you, thank you. I appreciate you coming on here telling me that. Thank you, thank you, thank you. Yes. You're the third student that's come on here tonight. The third student. Thank you, thank you, thank you. All right. So I'm gonna close out with this one last problem. And again, it deals with working out, ironically, on specific heat. Charles has increased his activity by doing more exercise. I should say, Professor TK the chemist has increased, because look, I gotta drop this weight, y'all, for real. After doing a session of using weights, I have sore arms. An ice bag is filled with 125 grams of ice at 0.0 degrees Celsius. How much heat in kilojoules is absorbed to melt the ice and raise the temperature of the water to body temperature 37.0 degrees Celsius? Okay, now before I start this problem, Surrey or Shuri, you accidentally missed your chemistry final today. Are you sure about that? Because listen, well, first, let me ask you this. Are you in high school or are you in college? Because there's two different answers I can give based on which one it is. Are you in high school or are you in college? Before I say my response. Because that's not good. Either way, it's not good. Okay, so while we're waiting on your answer, in this problem, let's write out what was given. Okay, let's write out what was given. So I told you that you had 125 grams of ice. Okay. What I also gave you, because this is ice, that's in a solid form. You're also given the conversion of 1 gram of water being equal to 334 joules. Okay. You need to know that too. And because we're talking about specific heat, okay, of water, specific heat is equal to 4.184 joules per grams degrees Celsius. Okay, so you're in college. Okay, here's the deal. Depending on the type of teacher or professor that you have, but I'm glad you got it moved to the weekend. You better work that thing out, buddy. You better do that thing, okay? Because you got a second chance. Which chemistry are you taking? Chem 1 or Chem 2 or other? Something else in this problem that they gave you, 1 kilojoule equals 1,000 joules. Now, why am I giving this to you? Because they want you to calculate the answer in kilojoules. So therefore, for this particular problem right here, they gave you temperature as well, okay? They gave you temperature as well. So they gave you mass and they gave you temperature. Now, the temperature that they gave you, okay, I'm going to put degrees T because that, again, is the final minus the initial. They gave you 37 degrees Celsius minus 0.0 degrees Celsius, which of course you know is equal to 37.0 degrees Celsius. So they gave you all of that in this problem. So again, let me help you guys out to identify what you got. They gave you the mass of the ice. They gave you the change in temperature. They also told you, or we know from that chart, for the regions, you're going to need the 1 gram of water is equal to 334 kilojoules. The specific heat, that's also given to you, 4.184 joules per gram degree Celsius. And then that basic conversion, kilojoules is equal to 1,000 joules because they want the answer in kilojoules. So what are you going to do? If we go back up here to our formula that we talked about earlier, right here, you're going to use the one in yellow, okay? The one in yellow, where it says joules equals E times G times delta T, okay? So that's the one that we're going to use. So let me pull that down here so you all can see, okay? And we're going to close out with this one. So your joules is equal to your E times your G, which is your mass, times your delta T. Okay. So I'm going to take that 120 was 125 grams. Sorry, guys. I put 125 grams of the ice, okay? Times, again, on the very top, you got your 334 joules over the 1 gram of the ice. Let's cancel the grams of ice out. And now you know for this one, you're going to put on the very bottom 1,000 joules is equal to 1 kilojoule, because remember, the answer has to be in kilojoules, okay? So cancel your J's out. And now this last part right here, you've got to also find your temperature, okay? But before we put the temperature there, we're going to put the specific heat value, okay? Which is your E, okay? So you're going to put 4.184 joules over grams degrees Celsius. And then we're going to multiply that times the temperature, the 37.0 degrees Celsius, okay? So let's go ahead and cancel out those like terms also. The degrees Celsius gets canceled out, okay? We cancel that out. And y'all, you see I've ran out of space, right? And what I'm going to do, what I'm going to have to calculate, of course, is going to be my joules and my kilojoules. I got to get rid of those too in terms of the unit because we wanted the answer in kilojoules. So I'm going to have to do what? Let me plug these numbers in first, okay? So that way you all are able to see what I'm working with right here. So I've got 125 times 334 times 4.184 times 37, and then divide that by 1,000, okay? And so we get right here 6463, okay? But then we got to keep going because we're not done yet, okay? Yes, that's right. We got to convert. Yep, we got to convert that to kilojoules because we're not done, okay? So right here, I'm going to put it, hold on, y'all. Let me cut them down right here. Yep. So I've got 6,463. Again, this was from the joules up here that I had up the very top. And what I'm going to do is divide that by 1,000. Because remember, 1 kilojoule is equal to 1,000 joules. Okay. And I think I did too much. Yes. Divide that by 1,000. And I get 6.43. It's okay, Jay. It's okay. 6.43. All right. So listen, if you all can, yes, fantastic, fantastic. Good job. Kim the Great. Yes, Chemist in the house. Chemist in the house. If you all can do me a favor, because I know a lot of you all are nervous about this Regents exam, what I need you all to do, okay, let me switch my screen over, because I want to make sure that you all understand, okay? Matter of fact, let me turn it to me so y'all can see me. And I'm gonna go ahead and end this on YouTube. So YouTube, thank y'all for joining me, and I will see y'all tomorrow. I'm gonna go ahead and check.